Next, we look at chimneys, ventilation, and using electric to heat water and more. It's important to have a properly functioning chimney system so the products of combustion can be safely removed from a home. Carbon monoxide is one of the most dangerous of these byproducts, and it comes from burning any fossil fuel. So chimney issues are a major life safety issue. Most older gas boilers and furnaces have what we call naturally drafting chimneys. The combustion gases exit the home through the chimney using only their buoyancy, combined with the chimney's height. Naturally drafting chimneys often have problems exhausting the combustion gases because of chimney blockage, pressures, or wind inside the home that can overcome buoyancy of the gases. Atmospheric open combustion furnaces and boilers, as well as fan-assisted furnaces and boilers, should be vented into masonry chimneys, metal double-wall chimneys, or another type of manufactured chimney. Masonry chimneys should have a fire clay masonry liner or a retrofitted metal flue liner. It's not that unusual to find that many older chimneys will have deteriorated liners, or maybe no liners at all, and must be relined during furnace or boiler replacement. A chimney should be relined when any of the following changes is made to the combustion heating system. When a homeowner replaces an older furnace or boiler with a new 90% or more AFUE appliance or a heat pump. In this situation, the heating appliance will no longer vent into the old chimney, and the combustion water heater will now vent through an oversized chimney. This oversized chimney can lead to condensation and inadequate draft. The new chimney liner should be sized for the water heater alone, or the water heater in some cases can be vented directly through the wall, or when a homeowner replaces an older furnace or boiler with a newer one that has an AFUE of 80% or more. These mid-efficiency appliances have a greater risk of depositing acidic condensation droplets in chimneys, and the chimneys must be prepared to handle this corrosive threat. The new chimney liner should be sized to accommodate both the new heating appliance as well as a combustion water heater by the installer. You may also run across some fan-assisted, non-condensing furnaces and boilers that were installed in the late 80s or early 90s. They could be vented horizontally through high-temperature plastic vent pipes, but not PVC pipe, which is safely used in condensing furnaces. It's worth noting that this type of venting has been recalled and should be replaced by stainless steel vent pipe. If horizontal venting was used, an additional draft-inducing fan may be needed near the vent outlet to create an adequate draft. Floor furnaces may have special venting problems because their vent connector exits the furnace close to the floor and may travel 10 to 30 feet or more before reaching a chimney. Check to see if this type of venting or floor furnace itself needs replacement. While you're doing your inspection, if you happen to smell gas, you definitely have a venting problem that could affect human life or safety. Contact the local utility or heating contractor to have this checked out immediately. Let's take a look at electrical resistance heating. Electric resistance heating converts nearly 100% of the energy in the electricity to heat. However, most electricity is produced from oil, gas, or even coal generators that convert only about 30% of the fuel's energy into electricity. If electricity is the only choice, heat pumps are generally preferred in most climates, as they easily cut electricity use by almost half when compared to electric resistance heating. The exception is in dry climates with either hot or mixed temperatures. These climates are primarily in the southwest United States as well as parts of Texas. For these dry climates, there are so few heating days that the high cost of heating is not economically significant. Electric resistance heating may also make sense for a home addition if it's not practical to extend the existing heating system to supply heat to the new addition. Electric resistance heat can be supplied by centralized forced air electric furnaces or by heaters in each room. Room heaters can consist of electric baseboard heaters, electric wall heaters, electric space heaters, or electric radiant heat. It is also possible to use electric thermal storage systems to avoid heating during times of peak power demand. Electric furnaces are more expensive to operate than other electric resistance systems because of their duct heat losses as well as extra energy required in order to distribute the heated air throughout the home. Heated air is delivered through the home using supply ducts and then returned to the furnace with return ducts. If these ducts are run through unheated areas, they lose some of the heat through air leakage as well as heat radiation as well as convection from the duct surface. Blowers, or large fans in electric furnaces, move air over a group of 3 to 7 electric resistance coils. These are called elements, each of which is typically rated at about 5 kilowatts. The furnace's heating elements activate in stages to avoid any overloading of the home's electrical system. A built-in thermostat called a limit controller prevents overheating. This limit controller may shut the furnace off if the blower fails or if a dirty filter is blocking the airflow. But keep in mind, with any furnace, it's important to clean or replace the furnace filters as recommended by the manufacturer. Electric baseboard heaters are zonal heaters controlled by thermostats located within each room. Baseboard heaters contain an electric heating element that's encased within metal pipes. The pipes, surrounded by aluminum fins, help aid heat transfer and run lengths of the baseboard heater's housing or cabinet. As air within the heater is warmed, it rises into the room and cooler air is drawn into the bottom of the heater. Some of the heat is also radiated from the pipe, fins, as well as the housing. If installed properly, baseboard heaters will usually be found underneath windows. There, the heat's rising warm air counteracts falling cool air from the cool window glass. Baseboard heaters are seldom located on interior walls because of standard heating practices to supply heat at the home's perimeter where the greatest heat loss occurs. Baseboard heaters should sit at least 3/4 of an inch above the floor or carpet. This will allow the cooler air on the floor to flow under it. This airflow under and through the radiator fins so it can then be heated. The heater should also fit tightly to the wall to prevent the warm air from convecting behind it and streaking the wall with any dust particles. Electric wall heaters consist of an electric element with a reflector behind it to reflect heat into the room and a fan to move the air through the heater. They are usually installed on interior walls because installing them on exterior walls makes it difficult to insulate. If electric cost per kilowatt hour is lower in the evening, your client could benefit from a heating system that stores electric heat during evening hours when rates are lower. We call this an electric thermal storage heater, and while it does not save energy, it does save money because they can take advantage of the lower evening rates. The most common type of electric thermal storage heater is a resistance heater, with elements encased in heat-storing ceramic. Central furnaces that incorporate ceramic blocks are also available, although they are not as common as room heaters. Storing electrically heated hot water in an insulated storage tank is another thermal storage option. All types of electric resistance heating are controlled through some type of thermostat. Baseboard heaters often use a line voltage thermostat, while other devices use low voltage thermostats. Line voltage thermostats can be built into the baseboard heater, but they often don't sense the room temperature accurately. Since baseboard heaters supply heat to each room individually, they are ideally suited for zone heating, which involves heating the occupied rooms in the home while allowing unoccupied sections of the home to remain cooler. Zone heating can produce savings of more than 20% compared to heating both occupied as well as unoccupied sections of the home. Zone heating is most effective when the cooler portions of the home are insulated from the heated portions. This way it allows for different zones to operate independent of each other. You should note, however, that cooler parts of the home still need to be heated to well above freezing temperatures because you don't want pipes to freeze.